Hello, today we're going to be working with Runnables and the math library. It's going to be super exciting because this is the first time we get to see things on the screen that get to move around and have a lot of fun with it. And without us actually having to say, oh, click here or click there. So it's kind of like a little video game, kind of. So the first thing we're going to start off with is Runnable. Runnable is really, really cool. So what we're going to be doing here is we are going to be doing implements just like how we did with the mouse listener. So we're going to do implements runnable, and it's not going to require an import. However, we will get an error over here, and just like with mouse listener, we need to add in unimplemented methods. It's going to only have one, and it's going to be called run. We'll get to that in just a second. So let's go back into our initialize method, and we're going to need to start the run method. So the run method is going to run at the exact same time that we're looking for mouse input or keyboard input. So we need something to run in the background, and the entire job of this is to refresh the screen over and over and over again. This way we get like an animation. This is very similar to like when you drew in the textbook in the corner, and you drew the little graphic, and then you flipped it, and you created a flip book. Exact same concept here. We're just going to draw each thing with a slight change, and it gives the illusion of animation. So to create that, we're going to create a new thread. Now this is not inside of the AP curriculum. However, I think this is a lot of fun anyway. So we're going to do thread, and we have to start this thread. All right, so once we start the thread, we're going to be creating a brand new thread that runs just what's in here, this run method. We're going to want this to run forever, so we're going to do run while true in here. We also want this to take a little bit of a break, so we're going to do thread.sleep, and this is in milliseconds. So this would be 1 second. In our particular part, we're going to put around 20 milliseconds. That's kind of fast. We will get an error here, so we're going to hover over this, and we're going to surround with a try catch. Basically, what a try catch does is it tries to do this command, and if it doesn't work, we will get it will catch the error and do whatever we want in here. Kind of like, oh, we couldn't connect to an online web server, so we get a message that says you cannot connect. That's what try catch will be doing here. In our case, it's going to error out and and print out what went wrong with it. When we're in here, we're going to do repaint. And this repaint method, just like when we were doing mouse listener, will repaint what's here in graphics. So if I run this particular program, nothing fancy is going to happen. It's just going to have a screen with a box. So let's do some variables now. So we're going to create an integer with an x, and we're going to create an integer with a y. I'm going to initialize these pretty easily. I'm going to do x is equal to 0 and y is equal to 0. So what we're going to do here is we're going to do x and y. And just to make this really simple, whenever we do this, we're going to add 1 to y. So it would be y equals y plus 1. We run this, and it should start falling a little slowly. Okay. There are two ways of speeding this up. First, we could reduce the sleep in here. And this right here would allow more refreshes, which would give it a little bit faster of a drop. Or we could just add how many pixels we want to change per screen, per refresh. So this one we're going to change 3. So now we get our different motions. That's really cool. So let's see how we can do a couple other things. Now, one thing that I'm going to show how to do, and this requires the math library, is how to do orbits. So if you're not familiar with the unit circle, this would be a good time to take a little bit of a refresher here. But if you remember sine and cosine, that's good enough. So I'm going to give you the formula here. And the formula is going to be the x is going to be equal to the starting point, or the center of the circle we want to orbit, plus the radius times sine delta. Okay? And then y is going to be equal to the center plus the radius times the cosine of delta. Oh, I think I messed that up. It's their opposite. Cosine, sine. Okay? So, that is a big deal of how we get this. But how do we get cosine and how do we get delta? So the center we can kind of pick, the radius we can kind of pick, but delta is something that's always changing. So let's create another variable in here. Delta, and we're going to make that equal to 0. Okay. Now, every single time it loops, we're going to say delta equals delta plus 1. When we go into this, we're going to be using this exact formula here, and I'll just do the x for a second. Let's say the center is going to be 250. The radius is going to be 200. And the way we are going to need to do the math behind this, or the cosine, is we do math dot cosine, and then we can put delta in here. But, we're also going to get an error here because the cosine returns a double, and we want that to be an integer. So we're going to be doing something called casting. Now, if you've done the extra credit from the previous assignments, you already learned how to do this. But since this is a double, we can't store that as an integer. So once we do the calculation, we're going to store it as an integer by casting it to an integer so we can store it there. Now, this isn't quite right. So let's talk about that for a second. Delta is in degrees. Cosine wants things in radians. So if you're a math person, you understand what I just said, but just know that they're two different things if you're not a math person. Now, the cool thing about that is you don't need to know how to convert it. We have something that will do it for us. So we're going to be doing this. We're going to call something called double, and we're going to go rad delta. So radians delta. And the way that we're going to do this is we're going to type in the word math dot, and you're going to see a lot of things. Like you're going to say ABS, that's absolute value. Atan, A cosine, those are the inverse of those. There's rounding to the ceiling. There's tons of different things. I highly recommend just looking at some of these because they're a great resource. But there's one called 2 radians. And all we would have to do is type in delta. So we would get rad delta would be in radians. Perfect. So if I run this, we should see it won't run in a circle, but the x should be moving back and forth. There it is. Perfect. So let's look at the y. The y is very similar. We'd have the y. We're going to have 250 as the center as well. Let's say the radius is 200. But we still need math.sine, and we still need to use the radians. Okay, and they forgot that. Boom. Why don't you like this? Oh, I closed it there. Okay, so let's run this again. And we should get things moving in a circle. We can slow this down a little bit. I highly recommend when we're slowing it down using this. Because we really don't add half. You could do change delta into a double, and then you can add half a degrees to it if you would like. So there's tons of different ways of slowing it down and adding it. I highly recommend looking at how to round, and we'll be talking about random numbers very shortly. So, good luck, happy programming, and I hope you have a great week. Thanks and have a great day. Bye.